pass over to Brian. He's going to talk to you a little bit about how he uses PathSolutions TotalView 3 miles under the ocean with Station Aloha. Take it away, Brian.
Thank you, Mr. Zach. So I'm Brian Chee. I work for the University of Hawaii School of Ocean Earth Science and Technology. I wear many hats. One of the other hats is I'm also a senior contributing editor for InfoWorld magazine, and I'm also co-host and production manager for This Week in Enterprise Technology on the TWIT TV network. So anyway, I get to see lots of interesting things. I do lots of product reviews for different magazines and so forth, and I found TotalView because I was working on the Interop show network with a lot of, with Tim Titus, the founder. And it's like, wow. I've been using network monitoring for I don't know how many decades. Probably when I first started with AT&T, we had a custom network monitoring system for the AT&T network. But all the network monitoring systems that I've ever touched all concentrate on the hardware. The server, the router, the switches, and so forth. I needed something that concentrates on the path in between my devices. So I run the world's deepest underwater observatory network. We provide data and communication, data and power to science packages 3 miles underwater. Anyway, the whole trick about that is it's a bummer of a field service call if something breaks. I want to know about what's going on beforehand. And since we are that little red dot up in the upper picture, that's where the observatory is. The middle green blob is the island of Oahu, and we actually follow that brown piece. It's called the Kaena Ridge, and it circles around a grand total of 164 kilometers to that red dot. Now, I should point out, we have been visiting that particular spot in the ocean for the last 2 decades. But we have to go out with a ship, and the ship time costs about $50,000 a day. Then we have to drop it down, do our thing. We actually collect water samples so we can find out what kind of dissolved minerals there are, what kind of life is down there, and so forth. But we're only out once a month. That's all we can afford to go out. And everybody said there's got to be a better way. And the better way was we managed to negotiate, wrangle, twist arms, blackmail, whatever adjective you like. We managed to work a deal with AT&T. They transferred that cable to us for a whole $1, and then turned around and took a $2 billion tax write-off on that. So the cool thing is we are doing science, but for a lot less money. We're recycling. We're the ultimate recyclers. Our closest competition is Neptune Canada. They are at $600 million and counting. The Station Aloha costs the United States taxpayers a whole $2.5 million. Not a bad return on investment, eh? We are in the Maui Deep. You can actually see one of our, that's a camera tripod before we deployed it. So we actually have to bundle everything up. We literally just drop it. We actually have these glass floats to give it some, just a slight bit of buoyancy so it drops slowly. And we've gotten pretty good. We actually got our camera tripod within 3 meters of the target. And then we get down there with an ROV, and the operators are actually able to pull the pins to unlock the cables. And it actually we were able to plug in both power up to 300 watts per device and fiber optics. So again, we're 3 miles below the ocean surface. It is the first generation. Now, 3 miles, that's 7,000 PSI, 500 atmospheres. So one of our favorite tricks is we take some Jamba Juice cups, and one of our artistic engineers will draw different things. He likes doing Monet. And then we also take cups that school kids have done. We stick them all into a net bag, drop it down with our equipment, and then when we're done, we pull the pin and let it float to the surface and recover it. Those Jamba Juice cups shrink down to the size of a shot glass. Now, people ask me, well, why can't you put men down there? And I says, well, if you get a small, teeny tiny pinhole leak, that jet of water is now supersonic. In fact, depending on the pressure difference at 3 miles down, it's actually hypersonic. And my dean actually had a really good illustration for our legislators when they tried to cut our budget. He slammed a jar of strawberry jelly on the desk and says, this is what happens if there's a leak in one of our submarines. So that's the kind of pressures that we're dealing with. It is 100 megabits per second Ethernet. It is a proprietary AT&T technology. We actually have a retired AT&T engineer working for us that designed some custom Moldex boards that convert the proprietary AT&T signaling to 100FX. And that allows us to go and put standard equipment. I'm actually using standard SonicWall enterprise grade firewalls. I'm using Dell, a combination of Dell, Cisco, Hirschman, and a couple other switches. But most importantly, between those, I have at my main campus another set of firewalls with a VPN link. My TotalView server is actually sitting at my main campus. I'm able to reach across the VPN into the cable and start harvesting data off the switches and devices under the water. So one of the things that did happen that we were kind of surprised about is one of our postdocs built a distribution cable for us. We call it a spider cable. And we thought he had followed the specifications and so forth. And slowly we started getting some weird numbers. The data transfers were getting slower and slower. The video was breaking up. We started scratching our heads. And then Titus came over and we installed TotalView in 12 minutes and we harvested the information. And I go, Tim, what's that? And he goes, drill down. And then drill down. Where it says I have a crushed cable. Oh dear. At 7,000 PSI, when the postdoc built the spider cable, he did it incorrectly. And it's slowly smashing the cable. So unfortunately, a service call is a real bummer at 3 miles down. ROV time is $30,000 a day. Ship time is $50,000 a day. We can only afford to go out once a year. But what we were able to do, because we knew what was going on, is we purposely changed the equipment to 10 meg half duplex, so we had a much better chance of getting data through. So normally we don't like 10 meg half duplex. In fact, PathSolutions TotalView has a little tab so you can very quickly identify 10 meg half duplex, like old JetDirect cards for HP printers. But in my case, because I knew about it, I can mitigate the problems that we had. So it's a real interesting application. Tim sat there and goes, yeah, okay. He thought that was kind of a unique use of his data tab, but it works. And that particular piece of equipment, it continues to work. The square part, that's the main part of the observatory. That is the size of a VW Beetle. There are 2 tubes, silver tubes down at the bottom. They are approximately 10 feet long by 24 inches in diameter. They are milled from a solid billet of titanium. And that solid billet of titanium cost me $175,000 each. And oh, by the way, because it's such a risky machining job, they will not guarantee the work. So we had to get 3 of them made because the first one was cracked. And the only thing we could recover off that is scrap metal. So sorry, we wasted some of your tax dollars, but we tried really hard not to. You can see we have 2 camera tripods. In fact, this August when we go out, we can actually afford to go out. We're going to go and fix the DC power supplies, and we're going to go and turn the lights back on. You can watch stuff deep under the ocean. You can also listen to whales live. In fact, if you're lucky, you can probably hear an earthquake in Alaska. Anyway, the number one thing that I love, the network prescriptions and the daily weather report. I have a whole bunch of PhDs that are absolutely stunning scientists at physical oceanography, biology, and so forth. But boy, oh boy, do they try and tell me what to do in my job. It says, guys, you hired me for my expertise in IT. And they started actually taking time to read the weather reports. And one of the PhDs, reported and saying, we had a problem, but I fixed it. I go, what do you mean you fixed it? Oh, yeah, the weather report, gave me some information, and we went and pulled some more data off the system. And it said, there's probably a crushed cable. And he found out when he went into the data center that, yet lo and behold, there's a cable stuck in the door. A PhD. I swear these guys get a frontal lobotomy after they get their PhD. But, such is life. But the point is, people that have nothing to do with IT other than telling me what to do was able to understand the reports well enough to actually act upon it. So that means my students could do this. I could have an undergrad helping me out, fixing problems. Little things like saying, oh, you probably have a mismatch in your cables. These network prescriptions are absolutely amazing. And in our case, it actually almost gives us an entire FTE to work with. So we can send students out to fix things, and they have in plain English enough information to be able to fix these issues on the network. So that's my actual network. I've got HA firewalls going through, and the top cloud is actually dark fiber. It goes from the Makaha AT&T cable landing station, cross-connect to the TW Telecom POP, which then cross-connects onto the University of Hawaii network. Lots of fun. We get to monitor all kinds of things. And TotalView is saving me money. And I have very, very little money to deal with because the National Science Foundation saw fit to cut my budget. So the bottom line is, PathSolutions is saving me money and helping me stay afloat, even in these tough economic times. So that's our logo. It is the world's deepest power plug, and it's the world's deepest data jack. So, thank you very much.
Cool. Thanks, Brian.